Okay, so you'll see the Sterilite container, and in the Sterilite container I filled it up so that the water is about, I don't know, half a centimeter deep. The Sterilite container is not flat on the bottom, so you just fill it up enough so that there's water everywhere, about half a centimeter deep. I'm actually going to do something you're going to think is gross, but I'm going to put my hand in it, and that is in order to get a little bit more salt so that the water conducts and we'll get a little bit better results. Now, this piece of paper is not in the water, it's underneath the Sterilite container. So the Sterilite container needs to be not frosted, but clear so you can see the piece of paper underneath. Now, I'm not taking data on that piece of paper because you can't write on something that's underneath a container filled with water. So I have my own exact copy right here. And so I'm going to take these two little electrodes. These are just bent or out of shape paper clips into L shapes. And hopefully on the left you can see four AA batteries with the voltmeters black ground connected right in between, so 2 and 2. And then you'll see that one electrode is attached to the positive and the other electrode is attached back here to the negative. I don't think you can see that on the video, but the alligator clip attached to its negative. And so what I'm going to do is I'm going to immerse the electrodes in the water according to a certain pattern. Now this pattern is a line shape and a point shape. A line shape and a point shape, and each of the squares is 1 centimeter. So to make the line shape, I'm going to immerse the paper clip in water so that the line is fully immersed in the water, but the point, I'm just going to put, let's see if you can see that, I'm just going to put just the tip of the paper clip in there. So I'm going to get the paper clip in the water. Now let me just tell you something. This is really a two-person lab. This is really a two-person lab. I'm just going to tell you that right now. And you can see how I'm struggling just to get the paper clip to stay. I'm going to struggle really hard to get the single point of the paper clip to stay. Okay, well, I actually got it. Can't believe that. Okay, so what am I going to do? So what I'm going to do is I'm going to take the red end of the voltmeter, which has a little T-shaped pin. I'm going to immerse it in the water. I'm going to search around for where I can find 0 volts. So I don't think you can see that on the voltmeter. Let's see if I can do this. So I'm going to search around for where I can find 0 volts. So where can I find 0 volts? Wherever it says 0 volts, looking for 0 volts. Okay, I found 0, and it's 1 centimeter below where the point shape is. I know that because I'm looking at the squares. Looking at the squares underneath. Okay, where else is 0 volts? 0 volts is about 1 centimeter to the right of the little point shape. And then 0 volts is about 1 centimeter above. And 0 volts is about, is actually now about 1.5 centimeters on the left side. So what am I going to do? I'm going to take my form here. And I'm going to take my form here. I should probably get a hard surface. Okay, so I'm going to take my form here. It's the exact same thing. And every place where I saw 0 volts, I'm going to put a dot. I'm going to label each one of them 0. Then I can draw a potential contour just like that. Okay, what if we look for, I don't know, let's say 2 volts. Why not? So we're going to try different amounts of volts. Oh, where's 2 volts? 2 volts is about 1 centimeter above the origin of the paper. Okay, and 2 volts is also at about 4,5. And 2 volts is also at coordinates 7,0. So, what did I just say? I think I just said 0,2 is 2 volts. Then, let's mark it on here. So here's the origin. That is a location where I found 2 volts. 4 comma half and 7 comma 0 were all 2. Find a few more 2s on that side. I can draw a contour passing through all the points. Now a complete product would be this. Your students are going to love this because for each pattern I make my students find 5 dots for each electric potential. Let's try and get you to see this. Find 5 dots for each, 5 locations for each electric potential. So 5 dots for each potential, 5 different potentials, that's 25 total dots. And then in a different color, I ask the students to draw the electric field vectors, which always point downhill. So electric field vectors always point downhill to lower potential, and these are about equally spaced apart. So I would say that that's equal amounts of electric field, equal strength electric field. But if the lines were close together, I would expect students to draw longer lines to show a stronger field where the ISO lines are closer together.